Find a local extrema of the function x times cube root of x squared minus 4. Local extrema can occur at critical numbers. To find critical numbers, we have to figure out where does the derivative equal 0 and where's the derivative undefined. To find the derivative of this function, I'm going to use the product rule. The first is x, and the second is x squared minus 4 to the 1/3. That means f prime is 1, and we have to use the chain rule to find g prime. Bring down the 1/3, x squared minus 4 to the negative 2/3. That's the derivative of the outside, and 2x is the derivative of the inside. Product rule says we'll get f prime times g plus g prime times f. So that means the first term would be x squared minus 4 to the 1/3. And then for the second term, let's see, on the top we have an x times 2x. That's the 2x squared. And then on the bottom we've got the 3 from the 1/3. And I moved the x squared minus 4 to the negative 2/3 to the bottom. So I have to figure out where does this equal 0 and where is this undefined. To do that, I like to write it as a single fraction, so I get a common denominator and add the fractions. I'm going to take that first term and multiply the top and bottom by 3x squared minus 4 to the 2/3. When I do that, my numerator becomes 3x squared minus 4 to the 1. That's because when we multiply, we add the exponents. 1/3 plus 2/3 is 1. So now I've got 3x squared minus 12 plus 2x squared for my numerator, and my common denominator is 3x squared minus 4 to the 2/3. So combine like terms in the numerator, that's a 5x squared minus 12, denominator 3x squared minus 4 to the 2/3. The derivative will equal 0 when the numerator is 0, and the derivative doesn't exist when the denominator is 0. So I have to figure out when does 5x squared minus 12 equal 0, and when does x squared minus 4 to the 2/3 equal 0. That would be when x squared minus 4 equals 0. So that means x squared is 12 over 5, so x would be plus or minus 12 over 5. Or x squared is 4, x is plus or minus 2. I've got 4 critical points here. So now I have to analyze whether this function is increasing or decreasing, and that will tell me whether these critical points are maxes or mins. So I'm going to draw a number line. On my number line, I put in my critical points, and I did put the square root of 12/5 into my calculator. I found out that was about 1.55. Then I'm going to pick a test value in each of these intervals. So I pick something smaller than -2, perhaps -3, something between -2 and -1.55. I did -1.7, etc. I pick a test value in each interval, and I'm going to plug those test values into my derivative. What I'm really looking for is the derivative, positive or negative, in each interval. So when I took -3 and I put that into the derivative, I ended up getting positive 3.76. The information that's important to me is that number is positive. So I put a plus sign in my number line. I do the same thing with the rest of my test values. I plug each of them into the derivative, and I find out that the function has a derivative that's positive, positive, negative, positive, positive. If the derivative is positive, that means the function is increasing. If the derivative is negative, that means the function is decreasing. So now I can see that the function goes from increasing to decreasing at -1.55. That has to be a local max. The function goes from decreasing to increasing at 1.55. There's my local min. 2 and negative 2 are not maxes or mins because the function doesn't change from increasing to decreasing or vice versa. When you give your answers, make sure you give coordinates, x and y values. So the x value of my max is negative 1.55 or negative 12/5. I'm going to take that, plug that into the original function for x, and that will give me the y value. So the 1.81, that came by taking the negative 1.15 and plugging that in for x. Same thing with the min. I took the positive 1.55, plugged that in for x, and that's how I got my y value.